Hello everyone. Welcome to the solution of LeetCode problem 2092 named Find All People with Secret. In this problem, you are given an integer n indicating that there are n people numbered from 0 to n minus 1. Now, you are also given a zero-index two-dimensional integer array meetings where meetings of I is x, y, and time. Indicates that the person X and the person Y have a meeting at the time I. Now, a person may attend multiple meetings at the same time. Finally, you are given an integer first person. Now, the person 0 has a secret and initially shares the secret with the first person at the time 0. Now, this secret is then shared every time a meeting takes place with the person that has the secret. More formally, for every meeting, if a person xi has a secret at time I, then they will share the secret with the person yi and vice versa. The secret are shared instantaneously. That is, a person may receive the secret and share it with the people in other meetings within the same time frame. Now we have to return a list of all of the people that have the secret after all the meetings have taken place. Now we may return the answer in any order. This is the pretty straightforward problem statement. I hope you understand it, and I will explain the example in the next algorithm section. Now here, to understand the algorithm, we have taken this example. Now, here there is a connection, or we can say that person 0 is connected with person 1 initially, and they can secretly share the message at instantaneously. That means at that second 0. Now, person 1 and person 2 is connected, and to share the secret, person 1 needs 5 units of time to the person 2. And to share the secret, person 1 needs 10 units of time to share the secret to the person 5. Similarly, person 2 will take 8 unit time to share the secret to the person 3. Now, we have to decide how many person basically can share the secret. Initially, let's say the secret comes from 0 to 1. Now, after 5 seconds, 1 shares the secret to the person 2. After 8 seconds, or at the 8th second, the person 2 shares the secret to the person 3. And at the 10th second, the person 1 shares the secret to the person 5. So we can say that there are 5 people initially shares the secret. Now, I hope you understood the problem statement. Now the question is, how can we solve this problem? First of all, this is a pure graph problem, as you see with the example. Now, in which graph algorithm we should use to solve this problem? Here, we will use the Dijkstra algorithm. Why we are using the Dijkstra? Basically, Dijkstra used to find the shortest path from a specific node to any other node. But here, we can modify the algorithm and we will check whether we can reach every node from the node 0 by using the Dijkstra with the given time frame. So here the intuition is very simple. Suppose we are at this node 2. Now to reach node 2, we have to pass the minute 5. And to pass the secret from node to 3, the secret will pass after the minute 8. So here the intuition is, suppose 2 is parent and 3 is child. So the intuition is very simple. If the time of parent, which is 5, is smaller than the time of child, which is 8, then in this case, we can pass the secret from parent to child. This is the basic intuition. Now let's see how can we solve this problem by using this intuition. Initially, we are at this position 0, and 0 has the direct connection with the 1. So in the min heap, we will store them as the time and the value of node itself in this manner. So here we will store the value times 0 and 1, node 1 and node 0 itself. Now, what is the top element of the min heap? Which is 0, 0. So here the node is 0. That means this 0 is visited. So here from this 0, it has 1 children, 1. So at first we have to remove it. And what is the top element of the min heap? It is 0 and 1. That means node 1. So node 1 can also be reachable from the node 0. Now here, let's erase the node 0 and node 1 from the min heap. And for node 1, we can reach to the node 2 and node 5. So for the node 2, its minute is 5 and for the parent, its minute is 0. That means child time is greater. So we can reach node 2 and insert the value 5 and 2 into the min heap. Now, what is the top element, which is 5 and 2 in the min heap? So from 2, we can reach to the element 3 or node 3 because the child time, which is 8, is greater than 5. Now, let's erase this 5 and 2 first and insert 8 and 3 here. Now, for the node 3, which is the top element of the min heap, it does not have any of the children. So we have to simply remove it. Now, when we visited the node 1, its 1 children, which is 5, will also be inserted into the min heap. In those cases, we will insert the value 10 and 5. So here, suppose from 3, we will return and get back to the node 2. From 2, we will get back to the node 1. So here, our current time is 8 and node 1's children time is 10. That means we can reach to the node 5 from the node 1. So we have to remove it from the min heap. So far, the min heap will become empty. And we have seen that we have successfully visited all of the 5 nodes. Now, suppose let's take a visited array. And each time we visit a node, we will mark it as visited. Finally, we have to iterate into the visited array and store all of the node which is visited and return the list. And this is how this algorithm gonna solve by using the Dijkstra algorithm and using the min heap. I hope you understood the algorithm. Now let's move on to the code. Here we are given a function named find all people, which is integer n and 2-dimensional vector meetings and first person. Now we are taking a vector of pair as the adjacency list, and for each of the meeting we are building the adjacency list here by using the weight. Now we are taking a min heap which will store the pair, and we are inserting the node 0 and the first person with the time 0 into the priority queue. Now we are taking a vector of int answer and a visited. Now while the priority queue is not empty, we are storing the current element of the priority queue into the variable current and we are removing it. Now here, the person or the parent is current element, second element, and the person's time will be current element's first element. Now if the current person is already visited, we have to simply continue. Otherwise, make the current person visited, and we have to iterate into the adjacency list of the current parent. Here, the child is the iterator first element and the time is the iterator second element. Now, if the child is not visited and the parent's time is smaller than or equal to the children's time, we have to insert the time and children to the priority queue. Now, after completion of this while loop, we have to iterate from 0 to n, and if the current node is visited, we have to insert I into the answer vector. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.